There's a much quicker and easier way to get to that 128, and a more sure way. Um, we guessed at 128, but that's not really very precise. And we're in a very simple situation here, just a rock falling. There are other situations where stuff moves around in a more wild manner, and taking these little measurements and making approximations is not always accurate in those cases. So there's a better way to do this, a more efficient way. And that is, instead of making all of these separate measurements where we let the time interval be 1 second and then a half a second and then a tenth and then a hundredth or whatever, let's just have a general time interval of length. We'll call it h. So we're going to use algebra for this. We're going to use a letter to represent that time interval. If I call that time interval or that time increment h, then I can calculate how far the rock has fallen after 4 plus h seconds. So I just plug in 4 plus h into my equation. Remember, my equation was 16 times t squared. So plug in t equals 4 plus h. That gives me a value. Then I can also calculate how far the rock has traveled after 4 seconds. I subtract the 2, just like we were doing before. And now when I divide by the time increment, the time interval, the length of time, I'm dividing by h. So in terms of functions, it looks like this. S of 4 plus h minus s of 4 divided by h. And here I'm thinking of s as the position. S is the distance traveled. So we can actually calculate that out. And when you do that, something kind of nice happens. What we really want to do is figure out what's happening to that quantity. That's an average speed that we're calculating from t equals 4 seconds to t equals 4 plus h seconds, where we can let h move around and be whatever we want it to be. We want that average speed. We want to be able to look at it as the h, the time increment, gets smaller and smaller. So as it shrinks down to 0. So if you make that calculation, you'll see that the stuff in the numerator, after you multiply it out and simplify it, you can factor out an h from that, and that cancels with the h on the bottom. And then you get this really nice expression that still has an h in it. And then you just plug in whatever h you want. So we started out with a time increment of 1 second, and then 1/2, and then 1/10, and then 1/100th. 1/100th. Once we have that equation with an h in it to give us the average speed for any h, we can just plug in the h and see what's happening. And really all we want to do is let that h shrink down to 0. So it's really easy to see, once we have this expression, what happens as you let h shrink down to 0. And you can see that if you plug in, or we started at t equals 4, so if you let h go to 0, you'll see that you get an answer of 128 feet per second. It's much easier to do it the second way, where you use the h. This is called the method of increments. And that's what I'll want you to use and learn. That's what we'll use as we move forward here.